Okay, so this algorithm wants us to find the solution where for each group of repeating characters, we return the character next to the amount of consecutive repeating characters at the beginning of the input array, so-called compressing the string. And then at the end of the array, we return the new length. We must write this algorithm in constant space, so that means we cannot create an array. In order to solve this, we can only add to the beginning of the input array. As we can see in this example, if this clears it up, we have 6 instances of A, or rather, 2 instances of A, 2 instances of B, and 3 instances of C, and we return the new created array will be, or rather the first 6 indexes of the input array will change into this, and we return the length, which would be 6, because there's 2, 4, 6 indexes. And then, yeah, we can see this edge case here, and the same thing here. We return 4 because there's 12 of this index and 1 of A, and there's 1, 2, 3, 4 indexes at the beginning of the input array. And this solution addresses this by C keeps track of the current index in the chars array, where we keep track of the consecutive index, and I keep track of where we want to place our result at the beginning of the input array. And you see here we find the count for the specific repeating character in the array, and if the character count is 1, we just append the character to the correct position in the input array. Anything else, so if the count is more than 1, then we format we convert the integer to a string and print append or add all the digits individually into the appropriate position of the input array. And then at the end, we return I, which would get us the length of the newly created our result, which is add to the input array. And here we can see it's very efficient because, like the requirements needed it to be, the space is O1, or constant runtime, or constant space, and the runtime is ON.